I'm rusty. Okay. There we go. Okay, so until and unless we get a question from chat, the filler activity for today is going to be some ODEs homework. And the first question is just kind of straight up variation of parameters. I was saving this one to do on stream because I should be able to do it without too much trouble. The more interesting / difficult ones are down here, which are like perturbation problems. And 2 is not so bad. 3 is kind of a nightmare. So far. Yeah, it's really strange. Like it was really just thrown in to this perturbation methods like discussion, like variation in parameters. I don't know why. I was kind of shocked to hear like one of my classmates never learned it in their like undergrad ODE class, and like I definitely did. That was a thing that everyone learned. But apparently not. Anyway, we do specifically have to use variation in parameters here. And we have to get this very convenient formula. You know, this is just such a great formula. How could you not love it? See, I think the issue with variation parameters is it usually gives you integrals that are really difficult, right? This one is not so bad though. So for variation of parameters, hey syntax, we need the homogeneous solution first. And so I'm going to drop the subscript ones. I think they're doing that because it's related to problem 2. But the boundary conditions are slightly different, which is annoying. So I'm just going to drop the subscript one because it's not important. Actually, I'm going to put an H for homogeneous. Actually, sure. Checked my course grade like homework for linear algebra, and you got full points on everything reviewed. Hell yeah, you'll love to hear it. This we can solve it by eyesight. C1 sine x over 4. Eyesight is a weird way to phrase that. We can eyeball it. Inspection. Yeah. I think I'm smarter than Einstein. Comparing me to Einstein is actually an insult. Thank you very much. Oh, I was about to apply the boundary conditions. We do need to wait for that though, right? We need to get the entire solution and then do the boundary conditions. Yeah. So then the entire, actually, well, we should build up the pieces first. Let's not go straight to the entire formula. We want to get the Wronskian. Because we just don't have enough names for the determinant of a 2x2 matrix. So let's get a Wronskian here. Sine x over 4, cosine x over 4. Take the derivative of each of these. 1/4 cosine x over 4 minus 1/4 sine x over 4. Do you know AI stands for Albert Einstein, which is it's so smart. Wow. I didn't know that. That's crazy. It's like a job for convolution. Is it? I know what convolution would mean in this context. I'm more used to seeing with like Fourier transforms and Laplace transforms. Determinant 1/4 sine squared x over 4 minus 1/4 cosine. Oh, if this isn't an identity, I'm gonna be really sad. I mean, I think with Fourier and Laplace, you can still do it for BVPs, right? You just need to do it on a finite interval, and your derivative identities might be slightly different. Sine squared minus cosine squared, isn't that cosine 2x or something? This, oh, cosine minus sine. So it's going to be, well, they're both, wait, no, it's plus. Ah! I don't know how math works. They have the same sign. I was getting thrown off because they're both negative, but it's just negative 1/4. Yeah, I should have done that syntax. I just like to confuse myself. Okay, so that's our Wronskian. Not even a function, that's nice. Well, I guess it is a function, but it's a constant function. Okay, and then we're gonna need two things. We're gonna need to know the integral from x naught to x. I don't know how we're gonna determine x naught. If we do. Well, we probably do need to. Forgot to show 0 was in a subspace in an exam. Damn. That's that's one of those really annoying things. Where like that should always be true, right? But you still need to show it. Because those things are just like really easy to forget. Sine x over 4 over minus 1/4. Well, oh, well, that's just, we don't really have to do much with this. We don't, we can't actually evaluate it. Maybe that's why Zach was saying something about convolution. What is x naught? Is it, can we make it anything we want? I guess we're gonna have to make it equal to, well, I don't, I don't know what's happening. I was gonna need another integral with the other homogeneous solution. I don't know, there's really not a point in doing this. I thought I was going to actually evaluate something when I set this up. There's nothing really to evaluate. The x naught thing is kind of bugging me though, because that's what we wrote it in the notes, but I don't know, like we didn't say what x naught is. It might be arbitrary. Or like, I don't know. Slim, any amusing conversations on the bus lately or the train? People keep to themselves here. I've only ever talked to someone on public transit once, I think. that I can think of. That's like right when I first moved here. But it wasn't that interesting conversation. He happened to also be a UW student. I forget what he was studying. But no, like usually the bus has like or like the public transit here in general is a pretty decent mix of people who seem normal and are just trying to get from point A to point B, and people who seem like they could be crazy and you should try and avoid them. So I'm usually just kind of keeping to myself. Okay, so here's the book's discussion on the arbitrary constants. It actually uses different ones here, and that seems like a better system to me. Oh, never mind. Changing either of these adds a linear combination. Oh, sure. That makes sense. Well, okay, I don't know what they expect us to do with X naught. I don't know. Let's just see if we can figure it out. You have started trying to talk to people in public places, like sliding in someone's DMs, but IRL. So that's like my greatest weakness in life. I cannot talk to strangers. Um, I just have a really hard time with that. That's like, uh, just probably not gonna happen for me. Some guys were drunk or high at the train. When I was leaving, they started saying something to me. I'd hit them with the hand to the ear. I can't hear, but gotta go. Oh, nice. That's a good move, syntax. Like it kind of like defuses the situation. When I was I slid into someone's DMs. Uh, that's a good question. I'm looking at my DMs right now. I don't know. I hardly DM people. It's usually just if I have something to say and then I drop it. So I don't know. I couldn't really tell you. I don't really slip into people's DMs. I mean, that's true, but I do talk to a lot of strangers here, but they're like, you guys are all coming to me. I'm always like anxious about like, am I trapping this person in a conversation or something like that? And so it's thoughts like that that keep me from like uh approaching people in real life. So wait, this solution goes with this integral, which I simplified to that. Dx. And then we have another one that is y2 times that integral. And this one has a flipped sign. So this one had a negative sign built in, plus another negative sign from there. This one does not have a negative sign built in, but we do have a negative sign here. Now we have to somehow make this match with the proposed form of the solution up here. Okay. Also, one time he said he'd kill me because I was Only fucking one pussy, unlike him who was fucking What? And his sister's husband was a foreigner and they moved there. I had not said a thing. A new random guy also on the train. That dude has issues. What the hell? Was it like the same dudes who were drunk or high? That's a wild thing to say to a stranger. Different place, different time. Okay. He was probably on something though, or at least recently was. Could sit in the back of the bus and start a stream there. Maybe people approach. That's true. I did do a few, or I've done 2 IRL streams. I did do one where I just like walked around a park, and it was a lot busier than I thought it would be. I was really self-conscious about doing it though. I'm sorry you had that experience on public transit syntax. I never had like a the only negative experience I've had in public transit has been like funny negative. In mind, at least he was going on shit about me and not the old ladies. That's fair. Like the weirdest thing that's happened to me on public transit is I was riding on a bus at night and it was pretty freaking empty. And this one homeless dude, which is where like the place where I went to college in Hawaii, like the homeless people had like some personality. Like I actually got to know like 1 or 2 of them. And there's one dude who you could pay to rap for you. And that's not like related, I guess, but I recognized him. He got on the bus, and I don't know if he recognized me or not, but it was like an empty bus, and he sat like right next to me, despite there being plenty of seats available. And I would have minded that, but he had like an entire hamster cage with a hamster in it that he was carrying onto the bus. And I don't know why. Like I don't know where he got the hamster from. um so yeah, like he just like sat next to me, neither of us said anything, and I just dealt with like hamster cage smell for the bus ride. I think he got off put before me. And that's the weirdest thing I've had happen to me. I never had someone like be aggressive. Is emotional support hamster? Maybe, yeah. Aaron, I think you put that question in my chat before. That's I don't think I can do that question. I'm sorry. Hey, Skirtle. Meow meow meow. I need to bring the question down here so I can like see both of these at once. I need to make this match with this. So we have 2 things with cosine. Oh wait, we should do the well, how do we do the boundary conditions? When these integrals are still here. Penn Center said he'll start doing some JE problems during Wednesday streams. Ooh. Could be very popular, especially if he streams it to YouTube too. Executive ability is prominent in your makeup? Oh wait, I was imagining like literal makeup like women wear, but they might mean like your emotional makeup, like your makeup as a person. I thought Skirtle had that executive makeup, which I guess maybe you do. Fortune is too true. See? Executive Skirtle. I should be using a dummy variable. And work when I do, but outside of that, brain empty. It'd be funny to see you in work mode and seeing you actually like be professional, because that's the opposite of how you normally act. Yeah, I mean that is a common thing. Like you always act differently when you're at work. Space Lobster. You've been working on pre-calc Gaussian slash Gauss Jordan makes me sad. Oh, like with system of equations? Yeah, I'm sorry. That part of math, it's important, but it does suck to learn. It's really tedious. So Kramer, oh god, Kramer's law. Not fun. To self-teach all of it? Yeah, I'm sorry, Space Lobster. Good luck. Hmm. I okay, let's just see what the boundary conditions give us, because I feel like we have to do them now, but I'm a little confused about how this is gonna play out. Hey, BR Gaming, you know it. Sign a pirate. Oh man, that doesn't even give us cancellations. Hey Leo, the trig aspect. Yeah, trig is another tricky one. It's again really important, but trig is tough that first time around. Sorry, I don't mean to scare you. It's all important stuff. It's good to know it. You're scared too late? Oh, well, sorry. And what does y minus pi give us? There's no monsters under my bed or my closet. It's just Kramer's law, Gauss Jordan elimination, and trig. Yeah. Easier with exponentials than sine and cosine. Maybe. We do have to get the final result in sine and cosine. I wouldn't be opposed to doing exponentials. I don't necessarily see the benefit right now, though. I figured out what the hell this is. This is the same thing, but this one is this is like the positive, this is negative. They did a plus minus trick, and I don't know why they would do that. But I think I see how to proceed with this now. Sorry, Space Lobster. Good luck. Please let me know if you have a question, and if I'm not around, you have a question. The second person in this list, Actual Education, also does like math help. Hey, Arav. Uh, yeah, I guess you could relate this to Fourier, couldn't you? So if we add these two things, 0 equals root 2c2 minus 4 root 2. It's not to minus pi. T over 4 dt. This is just a number. Is 4 times this integral. It's like a point I made in quantum computing video. You technically don't need complex numbers, but you want complex numbers. Oh, that's fair. Okay, and then I'm going to plug this condition back into the first equation. Now, root 2 over 2 times c2 minus 2 root 2 times that, or it's going to cancel. So I'm going to worry just about that piece. Okay. God, this is such a long equation. Ooh. This song is kind of... I don't know what to call it. Intense? C1. So, well, yeah, there's no music on YouTube. You just have to believe me. Because YouTube is way stricter about copyright stuff than Twitch is. Okay. Now what? Well, we want to group the things with signs together. So one reason why I really like doing math digitally now is I don't have to rewrite the same thing a billion times. Wait, ooh, this is bad. Wait, no, it's not bad. It's not bad. I thought these two integrals were canceling, but the bounds are different. Wait, I'm only supposed to have a 2. Say what? There's probably a reason for that. I don't necessarily think I'm wrong. I think they're just doing some tricky algebra. Okay, let's bring the form that we... Excuse me. Oh, I've been drawing boxes. Holy crap. Okay. I need to convert... Stop with the boxes. Convert that into that. So... with the cosine... Hey, Roksha. How does this X not? What the hell? How long am I streaming? I don't know. 2 hours? It more-ish? So... we have an integral here from minus pi to pi. The only way I can think of that we can possibly get that is if we somehow combine these two integrals. Hey, Famished. Sure is. The coefficients in front are a problem. Why do I need it in this form? Like, this is the answer. I just have to get it in this form, though. For some reason. Oh, you know what? Okay, so yeah, these fours out here actually are fine. Because of how they have... there's gonna be 2s coming from there. Ugh. Obsidian has Excalibur? I don't know what that is. Oak Okay, I don't know what obsidian is, but I do know Excal draw. I know it. Oh, wait a gosh darn second. If this integral is from x to x naught, and this integral is from x naught to pi, and the insides are the exact same, the difference is the integral from x to pi. Is that how we get this? Where does this other part come from? I assume Obsidian is like a program, or maybe a website. We do need to... Wait, what are we doing? We need to factor a negative sign out. Wait, what? Yeah, sure. Twist memes. Something about this isn't right, but let's just plow through those. How do you got a Obsidian to your algebra notes section? I don't know. This integral goes from x naught to minus pi. X naught, like, these bounds are backwards. X naught should be between minus pi and pi. Wait, okay. This is the exact same situation. I'm having a harder time thinking about it for some reason, though. uh, is it from x to minus pi? Question mark? And these bounds are kind of backwards. Yeah, you can try me twist memes. That those questions can be kind of tough, but you can post it. Mine it with a diamond pickaxe. Okay, so I want the thing with cosine to look... Oh! Wait. The integral from x to pi minus the integral from minus pi to pi. That is the integral from x to minus pi, or minus pi to x. Is that what we're getting at? God, why do we care about this? Ugh. Thought this problem was gonna be. I didn't think that this would be the hard part of the problem. Okay. Anyway. -4 sine x over... Actually, let me swap these bounds. Okay. This integral is equal to the integral from minus pi to pi t cosine t over 4. Oop. dt. Minus integral from minus pi to x t cosine t over 4 dt. Aha! This is looking more like it. Ooh. Is this extra... Is the 0 here a typo? Should we just remove that? Oh wait, no, I don't know. I'm assuming the problem is 6z0 squared is equal to z1 squared plus z2 squared. c6 squared. This is an interesting question. Okay. I feel like we have a roots of unity question. Like this is roots of unity. Because we can make this hexagon centered anywhere we want. And so we can put it at the origin. And if we have the 6th roots of unity, wait, how would that look? We always have a point at +1. We should have a point at -1. Isn't it 2 up and 2 down? Yes, okay. So I'm making a hexagon just with, like, radius 1, if you will, for hexagon. Like, this distance here is 1. But that's not super important because you can always scale it and this should be the same. And I haven't drawn scaling yet, to be fair. Okay, yes, this is definitely a roots of unity question, I think. It's definitely, I think, a roots of unity question. That's what I'm trying to say. So here, z0 is 0. Oh wait, we are squaring things. That does change this. Okay. If you remove the squares from this, I think this would follow really directly. It should still follow, though. Ooh, does it, though? Those won't cancel anymore. Kid with a phone camera. What's the toughest course I took? That's kind of like a personal thing. For me, it was probably discrete math in my undergrad. In graduate school, working on my master's, it's definitely asymptotic analysis that I'm taking right now. Discrete geometry. I haven't heard of that. Good luck with your master's, though. Yeah, the links in the center definitely have to be equal. You might be onto something there. Or trust me, I think we're going to be going in this similar direction. I do think there's a benefit to narrowing it down and choosing a Z naught. But like, this is arbitrary. Like, the same argument should work for anything. Hey, Quant. 12th standard. After 2 months, I have to take college. Decided to do a bachelor's in technology, but confused. Okay, like, what about? You love math and chemistry, but physics goes above my head sometimes, so which branch should I choose? Well, if you love math and chemistry, you should follow what you love, in my opinion. I'm generally of the opinion that you should study things that you like, not things that you think will make you money. As I mean, I guess if you have that luxury at least, but it's gonna be a lot easier to stick with something that you like, and getting a degree is difficult in the first place. Mechanical engineering or computer science or something else. If you're gonna ask me, choose the thing that you love, so math and or chemistry. But you're saying things that are kind of like not completely different, but pretty different from what you just said with mechanical engineering and computer science. In which case, like if you're just going to choose it based off like job prospects, I instead of asking me, I would look at job boards and see what the availability for different jobs looks like and like what they earn. So if we square all these points, hey Mate, in twist beams, I can. I'd rather do this first though. I think it's gonna end up being really similar, but I think this is just simpler to think about. So when we square z1 that stays put, when we square z4, it comes over to 1. If we square z2, the angle gets doubled. It's going to end up at z3. If z3 gets squared, the angle gets doubled. I guess it's going to end up at z5. Why am I doing that branch? I should make it a little more symmetric. And then if z6 gets squared, I guess it ends up at z2. That's kind of weird. These don't feel like they're canceling. Okay, let me catch up with chat. Discrete geometry studies convexity, duality. Oh yeah, that sounds terrible. I will probably hate that class kid with a phone camera. I also want to choose job oriented. My cousin said choose computer science later. He also says computer science has so much competition. Want to work abroad, leave my toxic home. Mate, whatever message you put in chat earlier, YouTube ate it. I don't see what you put. Yeah, Kwang, you should really just look like if you want to work abroad, especially just like look what countries you might be interested in, what kind of job programs they have for accepting workers from abroad. Because I think they'll often do like certain categories of jobs are easier to get in with. But I don't. It's always tough because like whatever you choose now, by the time you graduate, it could like things could change. So that's part of the reason why I say you should just go for something that you like. Um, okay, let me think about what Trust Me is saying because this graphical approach, I'm not, I'm a little bit lost with it. I might have screwed up one of my angle doublings. So Trust Me was talking about, was thinking about z1 minus z0. That should be some radius depending on the scaling. re to the pi over 3. The radius should all be the same for these, which is nice. Hey, one and only. Oops, Z1, how I named it, should be just R. We said, okay, so I should redo my naming to match what you did, Twist Memes. 1, 2, 3, 4, 5, 6. 2 pi over 3. We might just end up squaring these and adding them all up. RE Z3 is -1. Or negative R. I mean, really, we should probably keep it as RE to the I pi. Papadoria, I was trying to do it directly with 6 roots of unity. I think they basically are. They might be scaled. It might be translated. But I think it's basically going to come out to be the thing that makes the roots of unity a little bit difficult is that we're squaring everything. And I think this diagram where I try to square it is a little bit off. But my plan is to basically write out all these, square each equation, and add them all up. And I think we're not going to be far off. We just have the cross terms to deal with. Yeah, so all these R's being the same is for a reason. Twist memes. Hey, Milk. It's going all right. It's incredibly busy. We're on quarters. And so we only have 2 weeks left in this quarter before finals. And my life has basically just been homework for the last, like, I don't know, month and a half. Nearly there though. And then yeah, there's be one more quarter, and then I actually graduate. It's only a 1 year program, so it will be the end of my first year. But I'm also going to be graduating. It'll be the end of my only year, assuming I don't like fail a class, which I shouldn't. Okay, so twist means what I'm going to do is I'm going to take each of these equations and I'm going to square each side. So the first equation squared becomes z1 squared minus 2z1 z0 plus z0 squared is equal to r squared e to the I 2 pi over 3. This is going to be a little bit annoying to write each and every one of these out. So I don't know if I'm going to write out literally every single one, but we'll write out the first two at least. Four pi over 3. Dot, dot, dot. And then at the last one here, z6 squared minus 2 z6 z0 plus z0 squared is just equal to r squared. I hope that you're doing well, Milk. Lengthy, yeah. I don't know if there's a better way of doing it. So we're going to end up with, so from this column, we're going to get z1 squared plus z2 squared plus dot dot z6 squared. From this column, I'm going to factor out a negative 2z0. Then it's z1 plus z2 plus dot 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 plus z6. This problem up here at Ayush at the top of the screen. I'm going to scroll back down in a second. Did I say hi to you, Vasan, by the way? I'm sorry if I didn't, but hi, Vasan. And then from this column, we're going to get 6z naught squared. Now what happens here? So you have to write it out, probably. Factor the r squared out. We're hoping for cancellations with this. Two pi from squaring that angle. Hey, Aeneas? Varus? Sorry, I'm probably saying that wrong. Welcome in. Squaring that one. This one. Geometric progression. This is? Oh yeah, fair enough. Or is it? Yeah, we're adding two pi over 3 each time, right? Yeah. Good spot. I was gonna be more of a caveman about it. I don't know. I was kind of assuming these would all be 0 somehow. I don't know how to justify that though. They should have. Oh, they add up to Z naught maybe. Or Ooh, oh yes, they do. And I did this. No. Oh, it equals 6 times Z naught? That's perfect. This part does. You found a shorter approach? What is it? I agree that that should be the case. Anis. That's what I was trying to do initially, just letting Z not be 0. I got a little tripped up on justifying it for the square. It should be true, but I got confused on something, so I was trying this kind of brute force way for instead. So this is equal to 6 times Z naught, which is perfect. And the only thing we need to justify is that this is 0. For an equilateral triangle. Where's the... I know you can split a hexagon up into 6 equilateral triangles. How do you split up into 2 equilateral triangles? Oh, you're saying like this we can get 2 equilateral triangles. If I actually was able to draw. Okay, yeah, I guess let's draw it more carefully then. Um Okay, so Z1 has an angle pi over 3. That should be 2 pi over 3. 2 pi over 3 is somewhere up here. Z2 has an angle 2 pi over 3. It becomes 4 pi over 3. So somewhere down there. Z4 is 4 pi over 3, which becomes 8 pi over 3. Eight pi over 3 is 2 pi over 3, which we said was Z1. And does Z5 coincide with Z2? That's probably safe to say. So those are... So it's like the same equilateral triangle? Do we know that? Yeah, it should be equilateral. Because these two angles are the same. Okay, so you can make the argument that the imaginary parts cancel with those two, and the real parts add to -1, which cancel with that. I guess that works. Probably a lot faster. Clonk, your kindness will lead you to success? That's such a good fortune, especially for you. The fortune cookie god strikes again. Ooh, did I get a delivery just then? I might have. Yeah, I did a bad job with my drawing. And so I guess I was basically doing this down here just the tedious way. Okay, well, thanks for the question, Twist Memes. Um, unless there's another question, I'm gonna go back to working on this differential equation stuff. Yep, Papador, as soon as the drawing didn't seem to work out, I probably would have skipped it and come back to it. Or maybe I would have I could kind of send like a badly justified solution. Because like just from how the question is structured, you know how it should look. Or like what the argument should be. It's just actually making it a little bit finicky. Yeah, it is still a little bit long, even with that equilateral triangle thing, but I doubt there's a faster way. I think it should be true of any power. Assume W is an nth root of unity. Hey, color code Papa Smurf, that's a new one. Assume W is an nth root of unity. That would be a fun proof, Aeneas. I mean, well, fun, I don't know. It might not be fun, but... Actually, do you just prove it there? W to the K to the I. Nth root of unity. So, oh, you're doing like a geometric sum formula. W to the Kn minus 1. How do we know W to the Kn is equal to 1? Hey, energy. Is W... Oh, ha, fair, yeah. Okay, yeah, that's pretty slick proof, Aeneas. I like that. Set theory question? Yeah, sure. Hit me with it. Don't have an answer. I don't have a question because I know the answer to the problem. I was just curious how you would solve it. Oh yeah, sure, Papadoria. Well, you two are potentially typing out your questions. I want to check if I did get a package. 1 second. I did. And I don't want to show my address on stream, so let me do an unboxing, but like below my desk. Wait, let me check the label. It's not like misdelivered, right? Okay, okay. All right. Good night, Twist Memes. Thanks for hanging out. Okay, can you hear me? No. Okay. I thought you could hear me like crinkling the package. Does this have my address on it? No. Okay. Oh. Okay. Why is that there? The hoodie that I ordered for a band that I really like, Gojira. This is the art on the back. I'm like, isn't that sick? So yeah, I do have a poster from them too about the same album even. But the hoodie just like looks so cool. I've been eyeballing it for a minute. Okay, and then once again, let me just put this packaging away. Okay. Anyway. Okay, so Energy asks, what's your perspective on the intuitionist criticism of Cantor's set theory on the basis there can't be multiple sides of infinity since we can never construct an actual infinity to compare another actual infinity to? I asked E2 Pi this the other day. Everyone was saying they believe multiple sides of infinity. There's a counter argument, and I'm curious if you know any to the intuitionist argument. That argument's a little bit odd to me at Energy, like the intuitionist argument, because I would expect them to point out a problem with the actual proof that Cantor did, but they don't seem to be doing that. They seem to be attacking, like, I guess maybe one of the axioms that infinity exists. And I don't know that's like an actual axiom or not, but like they're basically like they're attacking the premise, not the actual argument. It sounds like. And I don't know. I mean, in math, like you never actually infinity isn't an actual thing in math. It's just the real way that you talk about infinity in the mathematical sense is just being able to go as arbitrarily high as you would like, which is as good as infinity, but it's philosophically like a little bit different than a literal infinity. And Papadori, I see your question too. That looks a little insane, but we can think about it. A reason the proof doesn't hold up in my view is that we can never construct two actual infinities to diagonally compare them, so there can't be a constructed proof for them. Well, what if the thing that we're constructing is just our, like, what if it's a finite length, but that finite length can be as long as you want? Like, what is the problem with a construction like this set? And maybe instead of going, like, I'll put an end here of like 10,000. But we could also have made this a million, a billion, a trillion. We can make it as high as we want. Well, Cantor's argument, it didn't even use the entire, like, Cantor just argued that what the set of natural numbers cannot be mapped to the interval 0, 1. Not even like minus infinity to infinity. I shouldn't do a closed bracket there. And so, like, when we compare sets in the mathematical sense, it's really about whether you can directly map each element of one set to each element of another set. And the intuition of that is that one set is bigger than the other. But strictly mathematically speaking, it's not necessarily size, in my view. Hey, Pokemon Adventure. So, like, yeah, at least when math is at its most formal, at its most like rigorous, like we're never actually talking about infinite things, I think. Or at least it's not like infinite in the same sense that we think of kind of colloquially or casually. That's an interesting point, though. Like, it's making me think. There can't be constructed proof for this in math. All infinities are potential in the sense we can never write down an infinite number of numbers. Well, if I sat here and wrote 1, 2, 3, 4, 5, 6, 7 until the end of time, just always going up by 1, is that an infinite amount of numbers? Like, I think it would be. It's not like realistic, but I don't know, and happy to keep on talking about this, but I'd like to give a little bit of thought to Papadori's question too. And I see Quant is posting something also. Hey, Sakno. All infinities are potential. I don't know, and like, I feel like even if you don't like my argument about arbitrarily large being different than infinity, or even if you don't like that, I don't know, I feel like we can construct infinite things because there's infinitely many numbers between 0 and 1. Like, no matter how many numbers, no matter what list of numbers you show me, I can always find another number that you haven't listed. And, like, I like this argument because it doesn't use infinity at all, but there's still infinitely many things between these two numbers. I guess, oh, that's funny. We're saying the same thing to for different results at energy about adding on another number. Logic, I guess there's a few things that are happening here. So, what I was just talking about is energy de Hampter is making an argument about Cantor's diagonalization proof not being valid, and like there can't be multiple sides of infinity because infinity itself can't be constructed. Humans can only construct finite things. And I was saying that I don't think I agree with that argument, but I haven't really thought about it that much. So we're just kind of like thinking out loud together. So yeah, and then I also want to give some thoughts to this question Papadoria asked, and then Quant also asked a question that I'd like to. I should at least read it and tell you if I can probably do it or not. You'll pretend you understand. Oh, sorry. Yeah, if you haven't heard of it, it's a little bit weird, but there's a famous proof in math that there's like different levels of infinity. Like not all infinities are the same. And energy de Hampter is casting doubt on that. Let Arden know the set of all real numbers. And hey, Rushback, you're tired from what? Aeneas, I'll read that in a second. Just trying to read what Quant's question is. Ooh. That's an interesting question, Quant. I think I can figure that one out. I want to give a little thought to Populary's question first, though, because he asked first. Just finished Resident Evil Requiem on Insanity mode? Ooh, that game looks cool. How was it? Educate why these should be in contradiction. ZFC is not constructive, and it's not supposed to be. Constructivism is too restrictive. Maybe it does have its merits. Yeah, I don't know enough about that part of math with ZFC and how it actually works. For alpha not equal to k times pi, where k is an integer, sum n equals 1 to infinity, sine of n alpha, converge or diverge? Ooh. Oh, what the hell? Contender for the best Resident Evil with Biohazard and Resident Evil 4. Ooh, interesting. I've never beaten a Resident Evil game. I played a little bit of a couple of them. First word out of my math, out of my mouth. What the hell? Yeah, this is. I would guess diverge. The limit of this thing as n goes to infinity is not 0. Isn't that good enough already to say that it diverges? I realize that there's some alternation happening here. Um, But it is necessary for a series to converge that the limit as n goes to infinity be 0, I think. Yeah. I'll open that up, Energy. I want to give a bit of thought to Popular's question and then Quant's question, but if there's time on stream, I'll do it a little bit later, or if not, I'll do it. I'll take a look through it off stream. Yeah, Ayush, that's kind of what I want to say. Hey, Winklebot. Because I'm thinking like just like the straight up test for divergence. Like the first thing that you learn in like your Calc 2 class. Oh, it goes the other way around. Or wait, no, logic. Never mind. Yes. Okay, yeah. I feel like this should fly. I wonder. If this is missing something. But had an exam on this? Oh no. I hope it went well, Winklebot. This is a really tricky thing when you first learn it. It is really helpful though, for a variety of things in math. How it goes? It's going all right. Got a lot of homework, but getting through it. How do you prove it doesn't go to 0? I mean, it's now time for a shower and then some rest. Fair enough. Rush back, enjoy your rest and shower. I mean, I guess how do you prove in general that the limit as x goes to infinity of sine of x like doesn't exist? Crushed it just like a week behind now from the extra study. Ooh, nice. I mean, nice on crushing it. Hopefully you can catch up. um, how do we show this? Like, I like we would need to do epsilon delta to actually prove this. Been enjoying Calc 2, so I don't mind doing more problems. It is intro for differential equations. Noish. Calc 2 is usually an annoying way. If you're getting some differential equations there, that can make it better. I mean, Papador, is this how you would do it? Or like you said that you already know the solution. I'm curious if this is what you did or not. Try multiplying the sum by sine alpha over 2? Hey, lonely me. I guess, yeah, for epsilon delta, you just have to show it's not 0. So you have to show that you can always be arbitrarily away from 0. I'm really bad at epsilon delta, though. I guess we should be thinking about the actual terms, right? Presumably we're going to need a trig identity for this. Do we want product to sum? It becomes a telescoping series. Wow. Sounds good. Lonely Me. I do need to finish this question, and then there's another question from Quant in the YouTube chat, and then it will be I can get to you. Oh god, torque. I'm kind of rusty on torque. I might be able to figure it out though. Sounds good, Winglebot. I appreciate you saying hi. Good luck with your homework. Sounds good. Let me yeah, the VOD gets published like immediately, or like it gets published even as I'm live, so it'll be there. And I can write you a reply on Discord too. Um Oh, okay, yeah, I see the telescoping now. That cancels with that. So we're just gonna end up with cosine minus alpha over 2. And then the last one doesn't cancel. Er. Oh. So ironically, we end up getting the same problem with the limit. That is funny. This is a telescoping series that should diverge though. Um I would rather not do an epsilon delta proof on this, but if we can just agree that that diverges. Let's see. That's a pretty cool thing with the telescoping series though. I did forget a 1/2 in my work. Welcome back, Rogstra. Ooh, that's interesting. So you converted n into n plus 1, arguing the limit should still be the same, because n is going to infinity anyway. The n plus 1 lets you do an identity. I can't criticize for handwriting, personally. I'm not sure if I understand what you're doing with this line here. Like, it feels like you're just stating the conclusion you want, but I don't see how it's justified. Oh, it's the next line because you square them and add them. Oh, that's clever. Okay, that. Ooh, that's a cool argument. I think it works. I'm not sure though. It's all good, Papadoria. Yeah, Colorcon, we do have that. Oops, that assumption built into the problem. I guess we only said integer multiple of pi. I guess rational could be a problem too. You're right though. The USA 80 topic for math next year includes calc, which is super convenient. Noish, you're ahead of the game. Okay, so I think we've gotten to the bottom of that problem. I want to show the Lonely Me's problem on stream just because I'm not sure I'll be able to do it. If someone I might be able to figure it out, but if someone wants to like potentially carry me through this problem, I'd appreciate it. I need to do Quant's question first though. Hopefully they're still here. Terry tells me serious thing was willing to help make the problem easier to consider. Yeah, like it's kind of funny that if you want the limit x goes to infinity, it's not important if you make it x plus 1 goes to infinity. Like the limit should still be the same. Yeah, exactly, Papadoria. Let me pull up Quant's question. Okay. I mean, well, you're asking like how to prove it, and it doesn't go to 0. And it's like, oh, I guess epsilon delta. Your proof is clever though. I don't see an issue with it, although it feels almost like cheating because it doesn't do epsilon delta. I do not like epsilon delta though, so if I don't mind avoiding it. Okay, so ooh, we have x squared sine of 1 over x. So if it was just sine of 1 over x, that's the special function that whose limit does not exist as x goes to 0, despite being bounded. But when there's an x squared in front, the limit actually does exist because it's getting squished towards 0. And so let's check the derivative of it to be sure, but it shouldn't be differentiable at x equals 0. The other two terms don't cause a problem, so who cares? So product rule. Oops, that's not how math works. This x squared cancels the derivative of that 1 over x. Ooh, so we get just a sine of 1 over x out. And so that means it's not differentiable at x equals 0. So A is definitely true. I assume there could be multiple that are true. So we'll check them all. Oh, really? Ayush? That's interesting. This is, if it is J advanced, is one I can actually do, I think. Usually I can't. Some of those is always a pain for any non. Yeah. For me, epsilon delta sucks for any function. Roxra, shoot. Okay, that you'd be the third question in queue. Let me. I do see the answer to your question quickly though. I'll at least give you a hint, and if you're still stuck, I'll work through it once it's your turn. But if you're doing this, my hint to you is to let, yeah, it's a u sub, and the u sub that's proper is sine of x, and so try that, and it should hopefully work out for you. You have that. Then what is your du? I think the way you show density is something like you observe it's enough to show e to the I alpha n is dense in the unit circle. Consider a differential equation. Ooh. That's cool, color cone. There's a positive real number delta such that f is increasing on the interval 0 delta. Ooh, that's an interesting question. Correct. Roxer, yep. And so when you do that sub, that cosine x should cancel with that cosine x inside the integral. You're saying the function is differentiable at x equals 0? The definition of f of x changes at x equals 0? Maybe I lied when I said I can do this question. Okay, I can see visually f of x should look, this is really hard to draw, but something kind of like this? You got it? Okay, awesome. It should be like a third sine cubed or something. Or a fourth sine to the fourth, I think. Yeah, that's right. So actually, okay, thinking about it visually, I believe that the function could be well defined, or the derivative could be well defined at 0. You're saying to do it from first principles. Oh, that's funny. Naman. Yeah, I do change my mind. I do think it's differentiable at x equals 0. It is a multiple choice question. We don't technically have to justify it. Um, oh, I saw you were doing the other definition for derivative, which would work too. Or it might be easier than this one. Well, I think yeah, that's fair. The other limit definition might be better here for the reason that you're saying. Oh, too late. Color cone. um, I think what I had written down, I think it would have worked out too, but I do like Ayush's suggestion of doing the other limit definition because we just simply get 2 for f of 0. Oops. This is a lot. Yeah, this is a lot quicker because the 2's cancel. And so that's 0. So the derivative, it is differentiable at x equals 0. Annoyingly. Positive real number delta such that f is decreasing on the interval 0 delta. Well, we know the slope is initially at 0 at when x equals 0, but they're talking about the open interval. I shouldn't have deleted the derivative. Or no, I never took the actual derivative. F prime x minus 4x minus 2x sine 1 over x plus sine 1 over x. So if x is a small positive number, that's negative. That's sine 1 over a small positive number is a small positive number. Wait, no, that's a big number. Nope. I was saying that sine of x is going to be about x, but that's not true here. That's more like sine of infinity. Um, you think doing d first is better? I guess would we do that with the second derivative? Oh, actually, yeah, that could be informative. Yeah, he counts it. Yeah, the B is a really tricky one to evaluate. Oh, wait, I didn't do this derivative right. Um, you should be cosine. Does cosine 1 over x have the same problem as sine 1 over x? It should, yeah. Well, this is a mess. What is the limit as x goes to 0 of this? Take the original function, analyze its behavior for interval h around 0. I don't know how. uh, I honestly, I think I'm going to move on because there's another question that's waiting and I'd like to get to it. This question looked easier than it is. For f prime, you can notice the first two terms will go to 0 when x goes to 0. We know the derivative exists at 0, though. That's what we showed with the limit. May not be continuous. I guess that's fair. Sure, Ayush. Honestly, I don't think Quan is here, and I feel like I'm realizing now they probably just gave me this to me just to like because they don't actually need help with that question. Um, Lonely Me does need help with their question, and so I'd rather move on to Lonely Me's question. I'm gonna type Lonely Me's name in chat. Yeah, I started working on it because I thought I could actually do it, but the more I started thinking about it, the more I realized that uh, they were just trying to challenge me for no reason, and I don't like it when people do that. If frame is not continuous at 0, if you consider that sequence. Ooh, 1 over 2 pi n. That's an interesting way of thinking about that. A lot of discussion. This question is on the internet. That makes sense. That is a really like tough one. Like there's a lot to discuss there. Okay, how does torque work? Kyle likes to get challenged for no reason. Hope you're doing well, Ren. Where's my blue book? Here it is. The mystical blue book. I should probably just Google it though, because I feel like, well, okay. RF sine theta, but what is theta again? Theta's angle when they're tail to tail. So can we do a dot product to figure that out? We not need a dot. No, we don't need a dot product. So that's like the 90-degree mark. (22°). So that means the entire angle is 90 plus 22. (112). So the radius, I probably want that in meters, right? So 0.15. 300 newtons. Sine 112. I think that's all we need to do. It's a little geometry, yeah. 0.15 times 300, that should be 45. See how good my mental math is. I'm not going to do mental math for sine of 112. If anyone can do that mentally, then more power to them. It is 45. Look at me go. 41.7. Do we need to do sig figs? I'm not going to do sig figs. Torque is, I guess, Newton meters? Does torque have special units? It's probably just Newton meters. Okay. I think Lily Me is not here, so let me type them up a message. Oops, not forward. Actually, let me just take a screenshot and spoiler it. Okay. In Rookster we can do that. Okay. So Rookshra, assuming you're here, The thing to like notice with this is that like this square root in the denominator. Oh, you are here. Okay, good. Oops, sorry. The square root in the denominator is complicated. I want to simplify it. And so the thing that I kind of like automatically try when I see an annoying thing like this in the denominator is just let u equal the annoying part. So I'm not so annoyed by the square root, and I realize that annoying isn't very like mathematical, but like whenever I see an integral with a fraction, I want to make a substitution like this work because it just makes life a lot easier. And it is going to work out here because x is basically the derivative of x squared. We don't care about like the 2 that's going to come out. That's fine. So du is minus 2x dx, and you might be writing it as like du over dx, which is more proper, but I'm used to writing it like that. So the integral becomes, well, let me, I like writing it like this because it makes it a bit more clear how the substitution works. I'm going to bring this minus 2 over to the other side. Minus 1/2 du is x dx. And notice we have an x times dx here in the integral. So that part can become a minus 1/2 du. This isn't how I normally like kind of treat u subs, but it's a cool thing to like see. So, this x goes away. This 16 minus x squared becomes u. The square root is still there. That's okay, though. And then the dx becomes a minus 1/2 du. And so from here, it's hopefully a bit more clear what to do. The minus 1/2 can come out front. And then I'm going to rewrite 1 over root u as u to the negative 1/2. And so now that's an integral that we know how to do. It's just a power rule. Yeah, exactly. So add 1 to the exponent, divide by the new exponent. So minus 1/2 plus 1 is positive 1/2. So 1 over 1/2 u to the 1/2 plus c. This flips up to become a 2. The 2 cancel with that 1/2. So it's just minus u to the 1/2 plus c. And then we unsub. So minus 16 minus x squared 1/2 plus c. There we go. Quinter. What? Trustworthy? Because you can tell them anything? That's kind of dark. I don't know why it's a Virginian, too. Yeah, that's kind of a scam. That fortune's just weird. It's probably a reference to something. It's showing us the du part. It is a little bit weird. So you could think about it the way that I did it here. The way that I actually do it in my head, though, is in the original integral, we had the dx. We want to get rid of that. We want to make it into a du. And so when I end up with a statement like this, I just divide whatever is in front of the dx. So I just want to isolate the dx. So I'd think about it more like, or I personally think about it more like this. And so this dx becomes minus 1 over 2x du. So when we do this u sub, it's actually a little more like this, where this x is still here, but it's going to cancel out because of this like factor that comes along. Ooh. So yeah, it is a little bit weird to get used to, but um it's a change of variables, and integrating X isn't the same thing as integrating in U. And this extra factor kind of fixes it. Like that's how you convert from integrating in X to integrating in U. Posted another one I see. All right, this one, it's the same concept. This denominator is complicated. I want to make it simpler. I want to do U equals 5 plus 3x squared. Perfect, yes. And they engineered this problem so that this 6x would perfectly cancel with that 6x. And then from there, the problem becomes a lot smoother. Oh yeah, you should. I was thinking that I should plug that into Desmos just to see how it looks. So yeah, I'll look from there because I think you know how to do it from there. Rogues for a bit. Same idea. Ooh. Wait, I was wondering why it's not equal to 2 at 0. There we go. What a weird looking function. I hate that it's not symmetric. I really hate that. Actually, I hate this function in general. Huh. This looks like something. This feels like a one of those Rorschach tests. I'm imagining like a vampire's like cloak, but like he has no head. It is just a weird function. Are there oscillations out here? Like I guess they'd be very slow out here. All right, fair enough. You know, I did say that if I had time on stream, I'd check out the article that Energy to Hamster linked. And I guess there is a minute now, because I don't think we have another question. So let's give this a little skim. Does time really flow? New clues come from a century-old approach to math. This doesn't imply the passage of time is an illusion. To avoid this conclusion, we have to rethink the reality of infinitely precise numbers. I haven't heard of that. The present appears nowhere in the existing laws of physics. Exactly that. Famished, yeah. Absolute values measure distance. So I don't know what the opposite of an absolute value is, but like the absolute value of -2 is the distance from 0. Um, there's going to be an evolved version of this problem that's a bit trickier with like the absolute value of x minus 2 or something. But if you're not there yet, then don't worry about it. But you can think of this one like still as distance, but a little bit different. Times woven together with 3-dimension of space, forming a new... Well, okay, yeah. Does that mean that... I don't know. It's called space-time, like, it's not just space. Okay, yeah, that's fair. I can get on board with that. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. So maybe think of like Feynman. Oh, hey, you have good timing, Energy. I was just looking at the article that you linked. And if your questions are like that, I could definitely help you out. I don't know how hard the USAD will be, but hey, you know what? That's good though. Like manifest that 1000 score. Predetermined view of reality held by Einstein remains popular today. Block universe. All right. Troubles posed by quantum mechanics. I was just thinking how much of like philosophy, at least the philosophy that I hear about like on Twitch, people will point to quantum mechanics as providing examples or counterexamples of things. But like, I definitely don't understand quantum mechanics. A lot of people who use it as an example don't understand it for themselves either. And I'm always kind of hesitant when I hear people talking about quantum mechanics in the context of philosophy, because it seems just like a really difficult thing. A lot of physicists, like, they just don't try to interpret it. Like, it's all like, shut up and calculate thing. Here's I'm feeling next year because you'll be the main team H. It's the 2 highest scores in the state, so lots of pressure. Ooh, wow. All right, honestly, if I was in your shoes, I would try not to think about that and just think about self-improvement. Like, don't try to live up to their standard. Try to live up to like your best standard, and you don't need to compare it to them. It may be better, maybe worse, but you just do your best. I'm just telling you what I would do at least, because I don't do well with pressure, and I think that's what I would tell myself to try and take that pressure off. At the quantum scale, irreversible changes occur that distinguish the past from the future. A particle maintains simultaneous quantum states until you measure it. The particle adopts one of the states. Individual measurement outcomes are random and unpredictable, even as the particle behavior collectively follows statistical patterns. Fair. To dispel the fog surrounding time and physics. Problem all along has been mathematical. Frickin' math, am I right? Time in general and time we call the present are easily expressed in a central mathematical language called intuitionist mathematics. That's what Energy was talking about before with Cantor's diagonalization. which rejects the existence of numbers with infinitely many digits. Huh. No more pi, no more 1/3. Are you just not allowed to divide 1 by 3 then? When intuitionist math is used to describe the evolution of physical systems, makes clear according to Gissen, time really passes and new information is created. This way to quantum-like unpredictability. Numbers are finite and limited in precision. Nature itself is inherently imprecise. That phrase I find like disturbing. I wouldn't like it if that was true, if nature was inherently imprecise. But I have thought about like it also disturbs me that we sometimes say a physical thing could have length of root 2, because how do you ever measure that? So I guess I can kind of see what the argument is. Like if it is infinitely precise, humans can never prove it. That's not as far as I know. I mean, what does it mean for nature not to be precise though? Like math is just how humans are understanding nature. I don't know. Huh. Do we know that time passes? I feel like that's just taking it for granted. I don't know. Based off the subject of like what this entire article is saying. 6, 7. Theory. The rest of classical physics implicitly assumes the existence of infinite information. Hmm. Any volume space is known to have a finite information capacity. Really? I didn't know that. This is a very weird idea. Huh. No more law of the excluded middle. Okay, yeah, it's getting really weird. Like, I don't know. I don't know what to think about this. Um, I wonder how like abandoning the idea of infinite numbers actually makes it so like time can flow. It is an interesting perspective though, where like you can get arbitrary precision, but it's more like you're running an algorithm to generate it one digit at a time. That's your kind of substitute for infinitely long numbers. Okay. This order is a little bit long, but it is interesting. I might stop here. Since like an interesting idea though. When was it published? 2020. Damn, like April 7th of 2020. This is like a lockdown article. All right. Well, interesting ideas. I do want to do a little bit of a. It'd be nice if I could get this homework problem done up here. I think I'm nearly there. Um, so I have the sine of x. Wait, what do I have? No, wait, that's cosine. You want a cosine to the integral from x to pi sine. So we need to make this look like this. And same this look like this. Um, how are we going to pull that one off? It seems like it will be true if we can justify. Oh, integration by parts? Mm. Okay. I don't know if I'm cooking or not. U is equal to, well, wait. No, I don't think integration by parts works. So I don't want to integrate or derive f. Um, I was just thinking in my head, Fembox would yell at me for saying derive. uh. If you want to keep lurking, then keep lurking. But if not, are you back from Australia yet? Hmm. I guess what I want to be true is this. Still, wow, that's a long trip. We come from the land down under. Well, I hope it's going well. Is there a change of variables that we can do here? How do we relate sine to cosine? I don't want to do a shift. I mean, any change of variables we do is going to affect the f, is the issue. A cell biology textbook. Ooh. That's cool. It's like about all the different parts of a cell? How cell works in all its components? That's kind of awesome. Say hello to others. You will have a happier day. Oh, that's a nice fortune. It's true. So, hey, Rex. Oh, you know what? It's not related to cell biology, but it is related to biology. What's it called? In my mathematical biology class today, we had a guest speaker. And he talked about this global burden of disease study that he like contributes to. Oh, you need to have an account, brother. I don't want to make an account. At least they have an example of it here. It's like an interactive tool that displays a bunch of like statistics on the global burden of disease, which is like it's measured as the number of years that people spend being like disabled, at least partially, from disease, or the number of years actually lost because people die from disease. It's like this is basically like a pie chart but with squares, where the size like represents the proportion of like the burden of disease that each of these things causes. Like COVID has a big old square, diabetes has a pretty big square, but there's like so many different tools and different ways of like visualizing this data. I thought it was cool. I wish you weren't forced to make an account to see this data, because I'm not going to do that, but just thought it was like cool. Wonder will this link do me any better? No, I think that's the same thing. Anyway. Um, I'm so close here. There's just a little trick here that we need, and I'm not sure what it is. Mathematician and biologists have to put their heads together and work out how to make people stop dying. I mean, they have been doing that for a long time. And another thing you mentioned was how which Bernoulli? You know what? I wrote it down. Doing algebra homework is just exponentials. Oh yeah, if you're doing calculus, I could see how that would become boring to you. I mean, I wasn't even doing calculus, and I found that stuff boring when I was learning it. Daniel Bernoulli. Daniel Bernoulli. Smallpox. So Daniel Bernoulli, well-known mathematician, he wrote basically the first mathematical paper to try to influence like public health policy. And I assume this is a translation of it. So it may have much like 1700 something. Yeah, he wrote a paper about smallpox, and he basically modeled it in the effect of inoculation, because they didn't have vaccines then. I mean, I guess people are doing that now with like the COVID modeling and stuff like that, but obviously you always need more. Yeah, this question was interesting because the only way they had to prevent people from getting smallpox was to inoculate them, which is giving them just a very small amount of smallpox and hoping that their body fights it off. That didn't always work, and it had like about a 1% fatality rate. But actually getting smallpox has a much higher fatality rate. And the question was, is it worth it to inoculate people despite that like risk of death? And Bernoulli came up with, yes, it is worth it if you measure worth in life expectancy. I found that despite like that 1% risk, you do get an average 3 years extra life per person if you inoculate. That's a pretty terrible like trade-off to have to make. Like it's kind of dark, but that's the situation they were in. they did not listen to him though, and maybe like 10 years later they found that cowpox, you can inoculate people with cowpox, and that's a lot safer, and it still prevents smallpox. So ended up being a moot point. But yeah, kind of cool. And I think this table, age by years, I guess this table tracks the same group of 1,300 children born at the same time. Oh, this isn't. I don't think this table's evaluating inoculation. This is just if smallpox existed versus not existing. I assume later on, it's a modified version of this table. No? I don't know. Maybe not. But yeah, cool stuff. Okay, with this, I'm thinking about like even and odd functions, but f is a general function. It's just continuous is all we know about it. I'm a little bit annoyed that integration by parts doesn't help here. Does it? I don't know. Oh yeah, that is like a table that an actuator would have, right? UV VDU. Shug. Hey, Shug, you're actually right. This is wrong. You called it. Hope you're doing well. That's a cool heart emote. You add 6 to 11 and get 5. Why is this correct? Because you're just always right, Shug. That's all the justification needed. Oh, if you're doing clock math. That's clever. I thought Shug was just beat me. I didn't realize it's an actual riddle. Negative plasma. Emulate what you respect in your friends. That's a good fortune. That's something that I've like tried to do. First clock math when you teach modulus? Yeah, true. It's a good one. The unit circle is just 1, 2, 3, 3, 2, 1 all over 2. Then root the tops except 1. Ooh. That's a neat way of remembering it. That's true if you're talking about what the y values, like for sine. I think that works. Yeah. Thank you, Shug. Love you too. Quitter. I simply made it so you get the bad fortunes, Quinter. You caught me. It's all rigged. Oh yeah, you can also root the one. But yeah, Rook, so that's more or less how I remember the unit circle. I only memorized the first quadrant up here, and then all the other parts I know are just like mirrored, so you can kind of figure your way around it. And even then, with that pattern you have for the y values, just flip the order, and that's good for the x values. Well, I say like just 1, 2, 3, not the entire thing. Wait. Oh, I'm confusing myself because I'm missing a line here. Duh. Needs to be 3 lines. So yeah, if the y values go like 1, 2, 3, the x values go 3, 2, 1. This is so annoying. There's some little trick they're doing. It's going all right. Lux, I'm in the last 2 weeks, and then it's finals week. Or it's like it's this week and next week, and then it's finals. Getting good grades in my classes so far. I'm only gonna have 2 final exams. For my programming, like scientific computing class, it's all just homework, not even a final project. I'm unfortunately gonna have the 2 finals I will have will be on the same day though, and that's gonna suck. But yeah, the amount of work has been pretty overwhelming. Like my life has just been homework for the last like month and a half. It's gonna continue to be until the end of the quarter, I think. But yeah, reason to be optimistic that I'll get good grades again. And sign up for my classes for next quarter. Roksha. Thank you so much for the prime. I appreciate it. Thank you. Oh, my background light isn't on. I don't know why I only just now noticed that. It doesn't even feel worth it. Like, I'm probably not going to stream for that much longer anyway. I'm going to turn it on, though. And Stooky! Welcome in, everyone. I'm just remembering that I didn't turn on my background lights. I'm doing that quickly. Good morning, people. I hope your stream was good. Faken, thank you for the follow. So yeah, what am I saying? What I'm working on right now in the background is this differential equations homework problem. It's just variation of parameters. This is really annoying algebra manipulation I've been trying to wrap my head around. But I've also been chatting to Finvox and just everyone about grad school and how that's going. Got a couple slides done at least. Hey, that's something. I mean, considering that you were trying to use ticks, which I haven't used for that for myself, but I've only ever heard people complain about it. A couple slides is pretty good. Yeah, Fembox is definitely keeping me busy, but it's almost done. For next quarter, I'm signed up for methods for PDEs. That's gonna be my like hard class, like the PhD level class. I forget what exactly the name of the class is, but it's something. It's about modeling cancer, which I'm really excited for. So 2Ls, or I think 1L or 2Ls is both acceptable. 1Ls feels right to me in the moment though. And then the last class is going to be calculus of variations, which I'm more thinking because I didn't like the other options that much. That class could go a lot of different ways. It's like really advanced calculus. From what the little bit of it that I've studied previously, in regular calculus, you're finding the optimal point of functions, like the minimum maximum point of a function. In calculus of variations, I think you're finding like you're optimizing functions themselves. You're trying to find a function that satisfies some constraint in like a minimal or maximal way. It's kind of hard to describe. The most famous problem from it though is the brachistochrone curve. Yeah, we'll do. Which is it's a physics problem. If you start at a high point A, and you're building like a ramp to point B, what ramp gives you the shortest travel time? And that's like the question that kicked off the calculus of variations as like a field, I think. And so you have to find a function that gives you this behavior. And I think I'm describing this right with this being calculus of variations problem. Oh yeah. Yeah, same. So I think we are going to talk about that Fembox, the Euler Lagrange stuff. I was looking at the professor for the class, and he seems like a big deal. Like he has a Wikipedia page, and like the stuff he's done is kind of impressive. Yeah. So, age 90. And he's done a bunch of stuff. So I think that could be a good sign for it being a really good class. But I feel like this class could go either way. Ugh, okay. So the question I'm trying to figure out is if you have an arbitrary function f, basically, like, is this integral equal to this integral? The answer should be yes, but I'm trying to find out why. I hope so too. I think it could be really fun. I'm worried that I won't like it, but we'll see. That like, I only really had two other options, and I wasn't a fan of either of them. Oh, thank you, Quinner. My camera does that sometimes for reasons that I don't know. Maybe because I move around too much. It gave rise to algebraic number theory. How to n-sect curves. Really? That's interesting, Dessen. Take OChem? Pass? I don't want to take OChem. I am kind of bummed because there's like a series of classes that looked interesting, but if I wanted to take it, I would have had to take the first class in fall because with the way that like the prereqs are, and then take the class like this quarter, and then take the class that I'm actually interested in for next quarter. But I didn't do the progression. I can't just like jump into it. It's all like stochastic processes though. Yeah, OChem. I'll let other people do OChem. That I didn't like even regular chem. I would probably hate OChem. Oh yeah, Dessen. I was just talking about which courses I signed up for. It's going to be methods for PDEs, cancer modeling, and calculus of variations. I've been reading about proteins makes me wish I was better OChem. Yeah, like uh you saying that you've been reading about cell biology is like really interesting to me. So I'd like to learn more about biology because it'd make it easier to like apply math to it. Keep track of those tricky electrons. Interesting. Rijo asks, circle with that equation. Find the equation of the line. Take center as xy. I don't understand the question, Rijo. What does it mean to find the equation of the line? Damn negative signs? That's true, yeah, those electrons are just negative signs. Okay, you know what? I want to go to Wolfram Alpha. Is this even true? Like, am I trying to prove something that's false? Let's let f of x just equal x as a test case. Zero. Now if we do it with sine, what happens? This should be... Okay, so I'm trying to prove something that's false. Good to know. Yeah, I should have been able to figure that out by the symmetry of the functions. It's a good point, Dustin. Well, how's this possible then? Hmm. Mr. Nikolai? It is. It's a true statement. Welcome in, though. Oh, I'm just agreeing with you. Math is very hard, yeah. Um, what's up, Roxra? When doing regression, what is E1? Like linear regression? It's gonna be either the slope or the intercept, probably. Oh, it might be error. I don't know. I need to see the context. It could be a lot of things. E1. Yeah, I'm not sure what it would be. I'm sorry. Like, that's E1 is a little bit too big. If it was like R squared or R, I would know that. E, I don't know if it has a universal meaning. Mr. Wisdom, welcome in. I'm best with things that are like first year university calculus and below. But I'm pretty good with like differential equations, linear algebra, and stuff like that. I'm currently a master's student studying applied math. So I'm not very good at like abstract algebra or number theory or things like that. But if you have a question, feel free to ask it. And if I don't know, maybe someone in chat knows, or I know someone who does know. Yeah, and actually we've had two first-time chatters, so I feel like I should do a little shout out. In case you're new to the math niche on Twitch, it's not just me. There's a whole like group of us who stream math here. And I think I was listening to E to the 2I pi might be live right now, even actual education. That's in like 45 minutes. Is this the method? The only way to find the integral equation as solution? Is it even a solution? Well, I mean, we have to specifically use variation of parameters for this differential equation. And I did that. I'm just trying to manipulate the thing that I got to match what they say the answer should be. But it's not working out so far. That might be a good thing to test, like plug it back into the differential equation, make sure I haven't made a mistake. Statistics and probability? It depends how advanced it is, but I know some. Might be the first error term, like the distance between the first point and the regression line. Ooh, maybe. Okay, works are posted. The context. Residuals. Okay, so if E1 is the residual, it's the difference between... Oops. I believe it's if your data looks like that and your line looks like that, the residual is the distance, the vertical distance from the point to the line. It's a measure of your error. It's usually like the absolute value. And so when you fit a regression line, you look for the one that has the minimum. You take these residuals, add them, square them, add them up, and you look for the line that has the least value there. You see it? Okay, good. Variation of parameters, yeah. There's a problem in Google. Solvable. Fair enough, Brijo. I don't understand what the question is still, so I'm not going to Google it, but I'm glad you got an answer. So yeah, variation of parameters. It's a little bit hard to summarize it. Let's see. If you have a differential equation like y double prime plus p of x, just some function, plus q of x, y equals Oh, not homogeneous. G of x. Um, and you let capital Y1, capital Y2 solve the homogeneous version. Okie dokie. Doing a game show right now where they knock using the Twitch. Uh, that sounds fun. Okie dokie. I think I want to focus on this though. Thank you for thinking of me, but uh, I think I'm gonna keep on doing this. Nudity class, we use quadratic equations that detect solutions. Is it binary? I don't know what that would mean here. Uh, in log class, we use quadratic equations that detect solutions. Are we talking about like the thing where you let y equal e to the rt? The quadratic thing comes from the second derivative. Um, okay, and so the part where this becomes variation of and homogeneous, the second one that you wrote, Dessen. The part where the variation of parameters comes in is that the general solution y of x, instead of being a linear combination of y1 and y2, it's gonna be like take like a linear combination, but your constants are functions instead. And so the task is to figure out what your v1 and v2 are. Because we know that y1 and y2 we can get from the homogeneous equation. And so if you take a bunch of derivatives and substitute things in, you end up with basically an explicit formula for the solution. Some constant a, y1, yeah, some constant b, y2, minus y1 of x, integral from x naught to x, g of t, y2 of t, over the Wronskian, which I'll talk about in a second, dt, plus, I want to check these signs. These signs do feel a little bit weird. Y2 integral x naught to x, g of t, y1 of t, over the same Wronskian, dt. And the Wronskian is the determinant of this 2x2 matrix. y1, y2, y1 prime, y2 prime. That's basically what variation parameters gives you. Maybe it works for degree 1. I never thought about it. It probably would give you the same thing as an integrating factor if it does work. Is my guess. I doubt there's ones for higher degrees. Probably get more complicated. Sorry, I'm just checking one thing. T10 Mac, thank you for the follow. Sorry, just give me 1 second. Hmm. Hey, T10 Mac, welcome in. Have worked out a simple example? I mean, I've done this before. I like, I can maybe try plugging the thing into the original differential equation and seeing if it works out. Um, I don't know though. So let me see. XD, I think posted their question about stats and probabilities. I want to look at that. Strange to hear that it still works in higher order equations. Okay, sorry about that. Yeah, Wikipedia is kind of up and down. Pareto distribution alpha equals 3 and theta. The absolute difference between 9 and 8. Huh, okay. But CTE be the conditional tail expectation. Ooh. So this is using some terminology I don't know. I might be able to figure it out. So we have Pareto distribution, alpha equals 3. Theta is a very specific number, 497 point something. Oh, it's buffering. I have 58 dropped frames. That's not many. I don't know when that happened. It's good on your side? Okay. Okay. Oh, okay, so there's the PDF. Alpha x sub m for x to the alpha. What is x sub m? Is that determined by theta? It's just a parameter, I guess? It might be the same as theta, or might be to have a relationship to theta. X sub m is the necessarily positive minimum possible value of x. Oh, okay, so x sub m is different. So I guess I should probably warn you, Mr. Wisdom. I'm probably not going to be able to do this. I'm trying, but it's might be the more I'm reading this, it might be a little bit too unfamiliar for me to figure this out. Spring break, like officially, it's just a week. It's gonna be more like a week and a half or more because I'm gonna be pretty much done with schoolwork early into finals week. Uh, so like a little over a week, I guess. Remember if we can do statistics. Like I haven't done the Pareto distribution, but I have done like I did do one class in calculus based statistics. I should theoretically know something about this. We go by quarters, so like this quarter goes January to mid-March, and then the next quarter goes mid-March or end of March to June, like the middle of June, and then I graduate. Conditional tail expectation. Yeah, sure, if you want. I'll show the question again. Okay, so this is just a formula that we could plug in. That's convenient. Or you can do something with expectation. Oh, good. Okay, you're saving me a lot of work with the thing that you just posted there, I think. Okay, so this is the expected value of the Pareto distribution for k equals. Or? Yeah, okay. I wish I was better with the formulaic side of math like stats or analytic number theory. Stats is pretty cool, to be honest. I wish I knew more about it. Um, so presumably, uh, presumably the question wants us to use this formula here, which I'm not familiar with this notation, like the caret. I guess it's from that. We'll get some function in something that we then need to integrate. Oh, God. What is pi sub q? Oh, nice. Found like 3 interpretations for each. Yeah, that I really hate that part of it. Trying to figure out the wording. Okay, so we have this formula here. So I'm kind of blindly fumbling my way through this, but I think maybe we can get somewhere. I don't know what pi sub delta is, but hopefully we can figure that out in a minute. And so we know e of x. Well, we can just use this. Theta over alpha minus 1. Then we want this bad boy. One minus theta over pi delta plus theta. To the alpha minus 1. Okay. Over 1 minus delta. I don't know how we're going to do the actual question. I'm hoping something obvious will shake out once we do something with this. Well, we need to figure out what pi sub delta is, I guess. That's probably a problem. Um... Oh, okay. Wait. The Q quantile. Is a quantile like a percentile? Okay. Okay. So if the fourth quantile gives you quartiles, or the 100th quantile gives you percentiles. Okay. Oh, good. So yeah, that's perfect. So we want to do pi sub 100. Or, well, it's pi sub delta though. Hmm. Probably the inverse. Uh, maybe. Algebraic stats? You know, I feel like maybe it's possibly the algebraists weaseled their way into stats. Absolute difference. So how I'm confused. If delta is arbitrary, how do we specifically get the 90th and 99th? Well, okay, never mind. I know how. We just let delta equal 0.9 and 0.99. Oh, yeah, okay. This is just, I think we're just plugging numbers in. So we have this formula here. We should actually plug in some numbers already. So pi sub delta, just let that be. Well, okay, this is a pain. Can my make Wolfram Alpha do this for me? Okay, so basically what I want to do is they want the absolute difference of CTE 0.90 and CTE 0.99. So that just means we already know theta, we know alpha. And now we know delta. We want 0.9 and 0.99. Thing is, what is pi sub 0.9? That's the thing that I don't know, I guess. Um, it's the cutoff point for x. It's the x value where the 90th percentile occurs. Or maybe. Do we know that? Can we evaluate it with the with the f of x? Or maybe do we want the cumulative one? I don't know when we're 0.9 of the way through the possible values. It's the integral of this from 0 to 0.9, which I think is just this of 0.9. Um, that's feeling right to me. Uh, ooh, not necessarily. It's something like that. I don't know if it's literally x equals 0.9 though. You found algebraic stats? The music stopped. Oh, you sure did find it. Why am I blurry? I don't know what's algebraic about this. You know, I don't think I want to know. um, I feel like I'm really close on this question. It's a multiple choice question. Interesting. So I guess, Mr. Wisdom, I think the only thing I don't know is how to get the value of pi sub delta. If you happen to know that, I think I can tell you everything else about the problem. Or like I'm trying to figure out how to calculate pi sub 0.9, basically. Seeing if on undergraduate stats, the PDF gives you crazy words. Um, I found my undergraduate, they called it engineering statistics. I thought that class was pretty fun. I had a really good professor though. I'm just gonna Google Pareto distribution quantile. Hello, Kurt. Um, Kurtosis. I feel like I heard of that. Maybe from Zach's stream. Um, I'm sorry. I do want to wrap the stream up. Wrap the stream up soon. And I don't think I know how to figure out this one piece. So I don't know. So yeah, Mr. Wisdom, like once you have this formula, like they've given us the values of theta and alpha. The only thing I can't figure out how to tell you is pi sub delta. But everything else, like delta itself is 0.9 and then 0.99. It's just a matter of plugging in the numbers twice and subtracting them. It's solved up to pi, basically. If you find a formula for it or something that just talks more about it, I could maybe figure it out, but I do want to go and get dinner. But, let me make sure that Zach is still streaming though, because I do want to have someone to raid. Otherwise, I would stall for Dr. Gold. Yeah, he's still streaming. Good, good. Okay. Yeah. And someone in the Discord might speak up too, but yeah. Thank you for trying with me. Sorry I couldn't get you the exact answer. You too, Femlux. It's always good to hear from you. Yeah, I guess YouTube stream will get cut off here. So, anyone here on YouTube, thanks for being here.